This man, NASA Administrator Jared Isaacman, just announced.
Jared Isaacman and NASA officially announced.
NASA is eyeing a triumphant return to the moon, announcing their ambitious plans to set up a $30 billion lunar base.
NASA is building a permanent moon base. Here's how right now, for the first time in over 50 years, humans are not preparing to visit the moon. They are preparing to stay. The hardware already exists. The contracts are already signed, and the companies involved are competing to see who delivers first. The moon base is not the mission. It is the rehearsal for Mars. Apollo was a sprint. 12 men walked on the moon across 6 missions. The longest anyone stayed was 3 days, and then it ended. Artemis is built on a completely different premise. At NASA's ignition event in March 2026, Administrator Jared Isaacman said it plainly. The goal this time is not flags and footprints. The goal is to stay. A mission needs a rocket and a crew. A permanent base needs landers, power, habitats, suits, rovers, and a refueling chain that works hundreds of thousands of miles from home. All of it has to function together, repeatedly, over decades. We are no longer planning a mission. We are building an ecosystem. 2 companies are building 2 radically different vehicles to get crews to the surface. SpaceX's Starship HLS stands roughly 50 meters tall, the largest lunar lander ever designed. What this involves is Starship launching into Earth orbit, stopping at an orbital propellant depot, taking on fuel from a fleet of tanker missions, then heading to lunar orbit, where it waits for the Orion crew to arrive. The payload capacity is unlike anything we have had before. Cargo, equipment, and eventually construction materials at a scale no previous lander has approached. Blue Origin's approach is structurally different. The company has been developing a crewed variant now called Blue Moon Mark 1.5, built to be ready on a timeline that could compete for the first lunar landing, currently targeted for 2028. Modular, stage descent architecture, built to scale over time. 2 completely different answers to the same question. How do we get people to the moon reliably and sustainably? For Mars, Starship's architecture scales directly to interplanetary missions. Every lunar landing is a data point for that longer journey. Before we build anything on the surface, we have to build a supply chain in space. For Starship to reach the moon, tanker variants launch from SpaceX's facilities and stock an orbital depot in low Earth orbit. The lander then meets that depot, takes on propellant, and continues to lunar orbit, where it can loiter for up to 100 days waiting for the Orion crew. Each handoff involves transferring supercooled cryogenic propellant between vehicles in open space, tight thermal constraints, precise timing windows. One missed step and the mission does not happen. As of early 2026, the ship-to-ship transfer demonstration required before Starship's critical design review has not yet occurred. That is the single biggest outstanding technical hurdle in the entire lander program. A Mars mission requires this same logic on a far greater scale. What we prove out on the lunar runs is the direct foundation for deep space. Once the lander is fueled and waiting in lunar orbit, the crew has to transfer from Orion into it. A docking operation was conducted 240,000 miles from the nearest rescue option. Under the revised Artemis 3 plan confirmed in February 2026, NASA will first test the docking of Orion with one or both landers in Earth orbit, evaluating rendezvous procedures, communication systems, and cross-vehicle compatibility before any crew attempts the same maneuver near the moon. Orion is a NASA capsule. Starship HLS is a SpaceX vehicle. Blue Moon is a Blue Origin vehicle. Different companies, different engineering teams, different contracts. They have to connect cleanly, autonomously, in the dark, far from any support. Spacecraft are no longer operating alone. They are operating as networks. For Mars, communication delays can reach 24 minutes each way. No one on the ground can intervene in real time. Every docking, every crew transfer has to be proven before we attempt it, somewhere we cannot quickly come back from. Everything we have covered gets the crew to the surface. The suit is what lets them actually work there. The Axim-U is built specifically for the lunar South Pole, where permanently shadowed craters hold temperatures far below anything encountered in low Earth orbit, and where the regolith is as abrasive as broken glass. This setup enables sustained operation in extreme cold zones for at least 2 hours, with full spacewalk endurance of 8 hours. We have already put it through real testing. NASA and Axiom crews ran full simulations in the Neutral Buoyancy Laboratory, weighted to replicate lunar gravity, evaluating mobility, communications, breathing, and cooling systems. The visor incorporates dust-resistant coatings, a deployable sun shield, and a 24-karat gold coating to manage solar radiation. An orbital test of the AXM-U is being targeted for 2027. The suit is not a detail. It is the difference between landing and actually operating. Those same requirements apply directly to a Mars surface suit. The engineering solutions differ. The philosophy is identical. None of these systems matters on its own. The lander only works if it gets refueled. The refueling only works if the docking is clean. The docking only works if the suit performs. And the suit only matters if there is power waiting when the crew lands. Every link in this chain is load-bearing. That integration challenge, not any single piece of hardware, is the real test of whether this base gets built. The Moon experiences nights that last roughly 14 Earth days. A solar-only base goes offline on a 28-day cycle. You cannot run a permanent human presence on power that disappears that regularly. In February 2026, NASA and the U.S. Department of Energy formalized a commitment to deploy a fission surface power system on the Moon by 2030, backed by a White House executive order mandating nuclear reactors on the lunar surface and in orbit. What this produces is at least 40 kilowatts of continuous electrical power, enough to run multiple habitats, charge rovers, and maintain backup systems, with the capability to operate for a decade without human intervention. 40 kilowatts, continuously through the long night. For Mars, nuclear fission moves from useful to essential. We first proved the architecture on the Moon. Landing is one problem. Living there is completely different. Blue Origin is contracted to deliver a lunar surface habitat via the Blue Origin lander, targeted for no earlier than 2033, providing long-duration living quarters, laboratory space, and life support for rotating crews. What this structure contends with is radiation roughly 200 times higher than on Earth's surface, temperature swings exceeding 280 degrees Celsius, and micrometeorite impacts with no atmosphere to slow them down. Earlier phases rely on pressurized modules delivered by cargo landers, giving crews a place to operate, while the permanent infrastructure is assembled around them. Small first, then grow. Every radiation shielding approach, every thermal regulation solution, every life support system we validate on the Moon feeds into the Mars habitat design. Living on the Moon is not about survival. It is about proving that living somewhere off Earth is sustainable at all. A crew limited to walking distance from their lander cannot build a base. Range changes what is actually possible. Phase 2 of the base plan incorporates JAXA's pressurized rover as a major international contribution, allowing 2 astronauts to live and work on the surface for extended periods without wearing suits, functioning as a mobile habitat that extends operational reach far beyond any fixed base location. On Mars, mobility is a survival requirement. A crew there operates with no resupply option and no realistic abort window. We learn how to do it here, where the stakes are high, but the abort window still exists. NASA did not build the Moon base the way it built Apollo, through one integrated government program with a single contractor hierarchy. Isaacman's framing at ignition was direct. NASA focuses on objectives only the agency can achieve, and lets commercial partners carry the operational burden. SpaceX builds and operates the heavy lander. Blue Origin delivers a habitat. JAXA contributes to the pressurized rover. Axiom builds the suits. Commercial providers deliver monthly robotic payloads. NASA certifies, coordinates, and keeps its focus on what comes next. The Moon base is being assembled by an ecosystem. If that model holds together, it is exactly how we approach Mars. Look at everything we just walked through. 2 competing landers. An orbital refueling chain has never been proven at this scale. Cross-vehicle docking hundreds of thousands of miles from home. A spacesuit engineered for 8-hour operations in conditions that would destroy Apollo-era equipment. A nuclear reactor built to run through 2 weeks of darkness. radiation-hardened habitats, pressurized rovers that turn a landing site into a base camp. Every one of those systems has a direct counterpart in the Mars mission architecture. NASA's base plan makes this connection explicit. The technologies proven on the lunar surface directly underpin the path to Mars, with each mission building capability for the journey that comes after. Mars is harder in every dimension. Communication delays make real-time intervention impossible. A crew on Mars is more isolated than any human beings have ever been, and no program has ever successfully sent people that far without first proving every critical system closer by. The Moon is that place. Every lander that proves it can refuel and descend reliably. Every EVA conducted in the cold shadow of a South Pole crater. Every night a habitat keeps a crew alive without sunlight is proof of a concept we need before we go any farther. We are not building a moon base to plant another flag. We are building the first permanent human outpost off Earth, and every system in it points toward the same destination. Mars is not the next mission. It is the reason for all of them.